I'm going to talk to you about some fundamentals of mathematical logic. Today, we will not address biological logic. It's going to be mathematical logic. This can be something extremely tedious and boring, but on the other hand, you will find out later as we move ahead with analysis, but also later with topology and geometry, that it is a very powerful weapon, which of course allows you to drive everything, right? So if you want to look at the introduction, I mean, this is something you can do later. If you go to the book of by Tao, you can read the introduction. But I'm going to yes, yes, I'm going to just go to the point. It's very fun. I like the way he writes, because he says, please don't study this appendix the way you might cram before a final. That is going to be useless. Instead, put away your highlighter pen and read and understand this appendix rather than merely studying it. I find it extremely wonderful, because this was always my problem. I told you that I was a horrible student. I always got very bad marks, because what I always tried to do was to read and try to understand. And I never, well, very rarely managed to do that. Okay, so let me remove all of this. Oop. Yeah, so so any mathematical argument is described or is presented in a sequence of did I say statement? Okay, any mathematical thing you write is presented in a sequence of mathematical statements, and we have different statements. You can have, for instance, you can have different mathematical objects like functions, I don't know, matrices, etc. And you have different relations, derivation, addition, multiplication, etc. And these statements, anyway, statements, they can be either correct or wrong. Okay, for instance, if I write that, this 1 plus 1, you know this by now, because we have learned how to do addition. So you're making progress after 6 months. It's 2. So this is correct. But saying that 1 plus 5 equals 10, this is a wrong or a false statement. But first of all, and since we're doing mathematics, and again, mathematics is not science, it's mathematics, we have to try to understand. First of all, we have to do a kind of dissection, if we want, of what we're talking about. So first of all, what is a statement? Okay, this thing here, I don't know, is not a statement. You usually say that this is an ill-defined statement, while this here, so this is because I'm sorry, I'm not explaining, because English is not a native language, and my accent is horrible. I'm going to write it down, ill-defined. This is an ill-defined statement. Well, actually, I don't know what is worse, my accent or my letter, my writing, probably my writing. Ill-defined statement, okay? And these are if you want well posed, well formed, well, yes, defined statements. Okay, but when you see this, you say, okay, of course, I mean, this is obvious, and this is just a waste of time. This guy has been talking for, what, 5 minutes now, and this I have not learned anything. And the point is that it's not always as obvious as this, right? Because another way of having, another kind of ill-defined statement would be this. This is not a mistake. This is an ill-defined statement. Why? Because since the division by 0 is undefined, the above statement is not well posed. Okay. Yes. Anyway, and then there's a very nice, yes, I like it a lot. In this book, which I'm using, all of what you know, everything I'm seeing is coming from Analysis 1 by Terence Tao. There's a very long paragraph which I like a lot. Maybe you have already guessed it, but I like a lot the way he approaches the matter, and that he has a long paragraph which I'm going to, if you want, yes, I'm going to read aloud now for you. Let me pick up the book, and this was on page 300 something. Wait a second. This because I have made some notes and I have written down here. Okay, I have it. So they say, he says, so he says, many of you have probably written ill-formed or otherwise inaccurate statements in your mathematical work, while intending to mean something other, to mean some other well-formed and accurate statement. To a certain extent, this is permissible. And then he says, so what he's trying to say is that sometimes, probably, when you have tried to solve an exam, in maths, physics, whatever, you have done some kind of dirty, not well-posed things like these ill-defined statements. But sometimes it's kind of fine. Everything you are doing is just to relax the forms. It's like when you say, I don't know, when you're speaking, I cannot think of any example in Chinese, of course, because my Chinese is horrible. But the only language that we share is English. And so you could say, this is, so for instance, you could say lead is more dense than, I don't know, aluminium, instead of saying denser, right? But still, you get understood, right? But it looks like you don't master the language, and it is not what you should do, right? You should do, this is denser, this is thicker. You don't say this is more thick, or whatever. Or I like it more. I like it, you should say like it better, right? I guess, because English is not my native language either. But anyway, when it is very important that you get used, and it will be extremely tedious and boring at the beginning, but it is very important when dealing with mathematics that you get used to pose very well the what you're working with, the sentences, so to say, the statements. In particular, when you are learning a subject, it is very important in keeping statements, as he says, well-formed and precise. As you get more confidence and knowledge, you can, of course, relax and go back again. I mean, it's not that we're machines and we need to write everything like in a computer program, which is, by the way, something that I cannot do. I cannot code because I find it extremely tedious. It is like writing a series of statements, always in plain logic, which might be fine. I mean, it is fun for maybe 10 minutes or 15 minutes. But when you have to write, I don't know, thousands of lines, I could as well commit suicide because I find it extremely boring, right? It's like, it's like saying, okay, I'm going to drink a little bit of my coffee, which is what I'm doing right now, by the way. And I realized that the coffee is cold. Okay, full stop. The logic way would have been something like, after having had a look at the cup of coffee, which is standing at, I don't know, 35 degrees to the right from the position of my head, I will follow these actions. First of all, I will, I don't know, trigger my shoulders muscles so that they can raise my arm. Then I will, move my elbow to describe, so that it can describe the distance which is away, to cover the distance from which this mark is away from me. And for that, I will estimate that distance to be of about those degrees that I mentioned before. And when I get close, etc., 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 right? So that can be extremely tedious and boring, and this is why I refused actually to learn how to program. Because if I had learned how to program, I guess that I would have programmed, and I didn't like it. Anyway, so, but the problem, so you know that the logic is going to be useful because you know this already, right? We have a powerful technique, which is the proof by contradiction, which leads to, well, to wrong statements. And since they contradict what was assumed at the beginning, then by contradiction, you can prove what we wanted to prove. But there are situations which are kind of very dubious, and it would be a big problem to try to use mathematical logic to things which do not belong to mathematics. It's like if I say, okay, I have put on some weight, I am 150 kilograms. That is kind of precise and objective. And you could indeed use mathematical reasoning to, to work with the sentence that I just gave you. But if I say, oh my goodness, I have put on a good deal of weight and I am very heavy now. Or I like a lot this color. How do you deal with that from mathematical logic, or even God exists, right? So we will not talk about these things here, but it's just to give you an idea of what I am trying to mean. Okay, now a very important remark that Tao makes in his book is that being true is not necessarily, and actually very frequently is exactly the contrary of being useful or efficient, right? Just to give you an example, if I write, I don't know, 14,523 is equals, I tend to write it twice, because I don't know why, because, so the equal sign, 14,523, right? This is completely true, but it's not very useful. Now, the statement, well, again, 14,523 is larger or less than, again, 14,523 is true, but not very efficient. Now, this statement here, this is a statement, is much more precise. But sometimes, and I'm going to take exactly the same example as Tao does, it may also be the case that a statement with, which you, sorry, a sentence with which you are working is completely wrong, but it's still useful. This is what we constantly do in physics, right? For instance, you approximate pi by 22 divided by 7. This is wrong. This is completely wrong, but it's useful as a kind of first approximation. Now, the important thing here is that in mathematical logic, the only important thing, the only really thing that you should care about is truth, and not usefulness or efficiency. And why is that? That's because truth is objective, meaning the contrary to subjective. Do you know the difference, right? Objective and here, subjective. When I say, for instance, that Tracy is very handsome, that's a subjective thing, because it depends on the subject, and that I am the subject. If I say I am starting to like a lot Yun Tao, that's also subjective. Or I dislike a lot Xiaodong, that's also subjective. It's not true, I like you a lot. But we're not interested in these things. Why? Because they are relative. They depend on the speaker. We want the absolute truth. We want things which always work. But we're going to be running into these boring and strange things constantly. But that's fine. That's the price to pay to get here, to get to an objective truth. And it is not easy, at least not for me, to develop the skills to derive objective truths. But this is the basic of science, and this is something that we learned from the ancient Greeks. By the way, again, in my to the best of my knowledge, and I swear to you that I have tried to look for this information for a very long time, and I have read many different articles and looked here and there. I think that logic, and this is something that you have heard a couple of times already, logic was developed only once in the history, meaning in a written way, of humankind in a place, and that was ancient Greece. Well, there was no ancient Greece as such. There was an agglomeration of different state cities, and all of them spoke Attic kind, well, not all of them, but they spoke a very similar dialects of Attic Greek, and not the Chinese. I'm sorry to say, not the I don't know, these pre-Columbian cultures in America, like the Mayas, Incas, I don't know how to pronounce this in English, Aztecas, I don't know. Not even the people of Egypt, so civilizations from which you would expect, because they had the cultural ground, if you want, or conditions to develop it. None of them developed the kind of logic that the Greeks worked out. If I am wrong, and any one of you knows more details about this, I would love to know details, because I wouldn't want to say something which is wrong. But anyway, so we have statements like this one. They can or maybe cannot be very useful or efficient. We have wrong statements which are efficient. But in any case, we have now learned what is a statement, right? And a statement is a different thing than an expression. And we're going to talk about expressions now. Statements, like we have seen now, are true or false. Now, an expression, on the other hand, is a sequence of symbols which produces some object at the end. So the outcome of that sequence is an object, a number, I don't know, a function, a group, anything, right? For instance, so this is very basic, but it will become more and more complex. So don't relax and say, okay, all of this is trivial. I'm not. We're doing, as I said before, a dissection or maybe a vivisection, because we're cutting it alive of mathematical logic. So this is again a statement. Remember that. For instance, 2 plus 5 times 2 equals, how much is this? 12. Okay. Okay, so this is a statement, again, statement. Now, an expression, however, is this. This is an expression. So it does not make sense to ask whether this is right, wrong, because it's not a statement. And again, expressions can be ill-defined. For instance, saying that 2 plus 5, writing that 2 plus 5 divided by 0 is an ill-defined statement. Okay. Or to evaluate, for instance, a function outside of its domain. Now, you can create statements out of expressions by using relations. And we have, so we're making a big jump now, because I have not yet introduced any of these relations, but of course you know how to use them, because you have used them your whole life. And a relation is any of these symbols: equal, less than, larger than, lies in, etc., right? Or by using properties. A property is, for instance, this number is prime, or this number is odd, okay? And then we can make a compound so composed statements by adding more and more, if you want, by adding basic statements using logical connections, like such as, and, if then, if and only if, etc. But we'll talk about this. Okay. I guess you don't have any question by now because everything was quite clear. Okay. Now, I promise to you this will become more and more interesting, but also more and more complex. So pay attention. So let's start with a few compound statements. This is a U compound statements. So first, conjunction. Conjunction. If X is a statement and Y is a statement, then the statement X and Y is true if X and Y are both true, and is false otherwise. Again, we're going to start with something very basic, but it will become quite, not very, but it will become quite complex very soon. So don't loosen up. So if X and Y are statements, then the statement X and Y is true if X and Y are both true. For instance, a very easy example now. 2 plus 2 equals 4, and 1 plus 1 equals 2 is true. And we're using a conjunction because this is our X and this is our Y. So this conjunction of two statements is true. While 2 plus 2 equals 4 and, whoops, I don't know, 7 plus 1 equals 10 is not. Another example, 1 plus 1 equals 2 and 1 plus 1 equals 2. So this might look fun and silly, but this is exactly the same category of conjunction. And of course, it is true. It looks boring, but logic is concerned again with truth, not efficiency. So logic, I mean, if logic was a person, that person would not make any kind of difference between this conjunction and this conjunction. Think as a computer, right? So this is correct, this is correct. I don't care whether it is silly or not. Now, we have a problem with, at least with some Indo-European languages, which are the languages that I know, not all of them, but I know a few of them. you know about Indo-European languages, right? Like English, Italian, I don't know, Spanish, Russian, Catalan, English, German. I don't know whether this is also true for Chinese, and it's up to you to tell me. Because, for instance, X and Y can be expressed in many ways. You can say X and also Y, o también, both X and Y are true. But then we have, we run into these kind of problems. Look, you can write X, but Y. This is logically the same statement as X and Y. Can you see why? But they have different connotations. So both this statement and this statement affirm that X and Y are both true. But the first one is telling you that X and Y are in contrast to each other, while the second one is telling you that X and Y support each other. Do you understand me? So these are two statements which are exactly the same thing, but they are expressed in a different way. And that's the problem with language, because language is not logical, and you will see that sometimes it can be extremely confusing. I will give you more examples later on. Okay, so we have seen conjunction. You know, by the way, a junction, okay, let's do a little bit of cheap philology. Conjunction. I do this because it helps to understand and remember the names. So in particular to you, I mean, this would be horrible, I guess, for me to learn in Chinese. But I'm going to look, this junction is like bringing together, okay? This is a Latin word, like many words in English. It is coming from Latin, and this means that you are bringing, you are putting together something. It's like in a crossing, like it's, when you have this road and that road crosses over there. This is a kind of junction, okay? And this con, this is coming from Latin cum, which means with. And by the way, for instance, in Spanish and Italian, con is written exactly the same way. So to say with, you say con. This is why it is easy for some people to, you know, I mean, people not speaking Chinese, to understand the meaning of this word just by reading it. And this is a problem for you, and this way I'm trying to help you. And I hope that someday you will help me when I learn these things in Chinese. And then you have, we're going to see now what is a disjunction. Okay, this is the same thing, right? But this is something equivalent to a denial of the thing that comes later. So this is an affix, actually, and in this case it is a prefix, and it means that what is coming here
is, oh my goodness, I'm making this extremely complex. So it's the contrary to the previous one. It's like, for instance, just to give you an example, in Spanish, the word hacer means to make, and that this, which is coming from from Latin, right? Deshacer is to undo. So you unmaking, okay? It's something which is going to be, undone. So this means that you are doing the contrary to con. So disjunction. Okay. Now, so at disjunction, if X is a statement and Y is a statement too, then the statement X or Y is true if, can anyone here guess what is the condition for this disjunction? Now that you know the meaning of the word. So how?
Either X.
At least one of them.
Sorry, come again.
Either X or Y is true.
Okay, close. Yes. So this will be true if either X or Y is true or both. And there is a subtle difference there. So this will be true if and only if, this arrow, right? This double head arrow. If either X or Y is true, sorry, this is not there. Or both. Just to give you an example. And watch out because, well, maybe because you are much smarter than I am, you will not have a problem. But this was extremely messy for me at the beginning until I understood it, because I think that I understand it now. So, for instance, 2 plus 2, and I'm really just rephrasing Tao now, so you can read this by yourself, but still, 2 plus 2 equals 4, or 3 plus 3 equals 5. What about this statement? So, by the way, this is, let me write it clearly. Or. So, what about this statement? What can you tell me about it? Well, first of all, this is a disjunction. But is this correct? In Tao?
Yes, I think it is correct.
I love you. 我爱你. Yes, it is correct. Because what is expressed is correct. 2 plus 2 equals 4, or 3 plus 3 equals 5. What about the rest of you? Do you understand why this is correct? Okay. Okay, we're starting now, so please wake up. I know that probably some of you have already started to fall asleep. In particular, Yang Jie, I think he was sleeping before.
No, it's interesting.
I'm joking. You should know me by now. Okay, now, okay. Also, what about this statement? 1 plus 1 equals 2, or 0 plus 1 equals 1. What about you? Shoutdown. Is this correct?
Yes.
You should say
Yes.
yes. This disjunction is correct, and then you would make me happy. Yeah.
Yeah.
Now, but there's a little there's a trick. There's some point here that there's no trick, for us. Again, I cannot but speak extremely highly of this book. I'm sorry, in Tao, but I am also in love with this book. It's not only you. I hope you're not jealous. I am in love with this book. It is a piece of art. So the point is that this word in mathematical logic could be two things. It could be exclusive, and this is what drove me mad for about 1 day, or inclusive. Now, do you understand the meaning of the words exclusive and inclusive? X means actually from or away from. Inclusive means kind of that you're taking it with you, so you're embracing it, or yes, this is actually something like well, anyway, I don't want to bore you. So this means that you are away from it. I mean, this in means the contrary. This actually means that you are moving towards, or you are in, right? So I can be inclusive with you. I consider all of you and say all of you are handsome, or I can be exclusive and say all of you are handsome, but for Xiaodong, who is very ugly, right? Don't take it personally. That was a meta joke. You should take it personally. I just called you ugly. But you know me. So, disjunction, what I'm trying to tell you, sorry, let's go back to being serious. Disjunction can be inclusive or exclusive. If it is exclusive, you really have to prove that one of the two possibilities is left out. You must exclude one. The first case is the contrary. You just need to include one of the two. Okay, let me summarize this, because I don't know whether you understood it. Again, it took me a long time. So, X, this is an X, or Y, by the way, what time is it? Okay. X or Y is true, can be read in two different ways. Okay, I'm going to call it this. If you consider an inclusive or, then X or Y is true, or both. If it's exclusive, then it is X or Y, but not both. It is either X or Y. Okay, let's see some examples. Yes, I'm going to delete this. You don't have to, what is this? Oh my goodness. Okay, sorry about that. Yes, NAD. For instance, I can tell you the following. Again, disjunction can be inclusive or exclusive, but by default, the word or is going to be inclusive, right? So to verify a disjunction, it is enough to prove that just one of X or Y is true. You don't have to prove that the second one or the first one is false. So for instance, the statement 1 plus 1 equals 2 or times equals we know that this statement is true without having to check this extremely boring multiplication. It's not boring, but it's not. Why? Because or in mathematical logic is going to default to the inclusive or. Okay? Unless I say otherwise. In that case, I will tell you, please, people, watch out. We're talking now about an exclusive or. So, from the point of view of Lady Logic, Mrs. Logic, or Mr. Logic, I don't care about the gender, this statement is as correct as saying 1 plus 1 equals 2 or 0 plus 0 equals 0. So both are correct. While in this case, I know that this is correct. This is correct. In the first case, just by looking at it, I know that this is correct, but I don't have an idea about this. And well, this this is of course wrong because I just wrote random numbers. Okay, but Mr. Logic or Lady Logic, they don't care about this. They say because we are considering an inclusive OR in our disjunctions, the first and the second statement are both correct, and everything is fine. So again, unless I say otherwise, this OR is going to be always inclusive. If we really want to use the exclusive OR, I will tell you. Or I will say, look, either X or Y is true, but not both. Or, and again, I'm just reading aloud what Tao has in his book, exactly one of X or Y is true. Okay? But it is true that in mathematics, this is what is dominating the disjunctions or logic. Okay. Now, we have now about 20 minutes because after that I will have to leave. And I think that's enough to go into negation. So we have had conjunction. We have had disjunction. Oops. And remember that these things are just very elaborated statements, right? These are compound, so the correct word, I was looking for the word. So the correct word is compound. These are compound statements, and they are built upon more basic statements. And we have seen two of them only, conjunction and disjunction. And please, 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 please remember this, because otherwise you will run into infinite mental loops. Okay, now the last thing that I'm going to talk about today, and by the way, if you want next week, we can have 2 lectures instead of 1 because we missed 1, is negation. Okay, so let's go for it. Negation. Okay. Now, negation. So let's again, if X is a statement and Y is a statement, then the statement X is not true or X, sorry, this is X, is false, or it is not the case of X, is called the negation of X. All of this is called the negation of X. And it is true and only true if X is false. And it is false if and only if X is true. Okay? Yes, but watch out, because again, there will be a very subtle thing here which can be confusing. Now, for instance, let me think of an example. If I write, yes, so it is not the case that 1 plus 1 equals 10. This is a correct statement. Of course, you could write it like 1 plus 1, like this. Okay, but this statement, when you see these words, you just realize that this is a negation. And this is a negation of what? Of this statement, X. And therefore, since we are negating X, it is a negation. And since the negation is correct, the whole statement is a negation, and it is correct. Now, this is now the difficult or a little bit difficult part. Negations can turn, actually not can, negations always turn and into or, into an inclusive or. So a negation is going to turn and it's going to convert it into an inclusive or. Can you give me an example for that? how? Give me an example for that.
For example, 1 plus 1 equals 2, and 2 plus 2 equals 4. And the negation of that will be 1. I 1 plus 1 1 plus 1 equals 2, or 2 plus 2 equals 4.
Are you sure
No,
about that?
no. I'm not sure. For example, 1 plus 1 is not equal to 2, or 2 plus 2 is not equal to 4.
Are you sure about that?
Not
But please don't forget that I always trying to confuse you on purpose. Because you listen to my voice, I am older than you, and then you think, oh, this guy must be right because he's older than I am. And that's not true. Okay. So, for instance, let's consider the following statement. Shui Hao has black hair, and Shui Hao is handsome. Okay. We have here an and. Shui Hao has black hair, and Shui Hao is handsome. What would be the negation of that? Wow.
I'm not handsome, or I have I don't have black eyes.
So the negation of that would be Shui Hao doesn't have black hair, or Shui Hao is not handsome. But it would not be Shui Hao doesn't have black hair, and Shui Hao is not handsome. Can you see why?
Because
I
it's
told you, it can be confusing. Inclusive for.
yeah.
Okay. Okay, so again, and I really want to stress it, I am still in all the line of the text. What I am explaining to you, everything is stolen from Tao's book, just to make it clear. It's not stolen, but I am borrowing it, and I am explaining it to you. So I am actually just a reading machine, if you want. I have assimilated all of this, and I am, using additional examples, etc. But anyway, but the book is closed. I have some notes, and now, but I have here a clear example from his book. For instance, if x is an integer, what is the negation of x is even and non-negative? So see, x, or let's say a, because I don't like, for some reason, I don't like the letter x. Let's say a number, any number, a is an integer, and I tell you a is even and non-negative. What is the negation of that? I will write it down so that everybody can read it. So I tell you.
Yeah.
A
It's the integer.
is even and non-negative. So what is the negation of that?
Do we need to consider that a is not a integer, or
I don't
we
know.
just so A is positive, or A is not integer. Yeah.
But it
Why
can
do you
be
change?
0.
Follow the order. First of all, the first so it's a compound statement.
Yeah.
Remember, and the first one is even, and the second one is non-negative. Can you follow the same order?
Sorry, my roommate is saying something.
Yeah.
Yeah. So A
Look at this. What is so? Let's go step by step. Don't
Yeah.
try to run, and it's fine if you don't know it, because again, don't worry. These things can be confusing, and it just requires practice. It's like riding a bike. You fall at the beginning, but then you know how to do it. So you have two things here. What is the contrary of even?
Odd.
Odd. Yes.
Yeah.
OD. Yes.
Yeah.
Wow. Yes.
So
And what is the contrary of non-negative?
is positive and
Okay.
0.
I think it's not natural number.
Yeah. It is natural number.
Sorry. Just-
No.
No. Come on. Non-negative.
Yeah. It's
Are you sure?
it's positive and 0. Yeah.
Or,
People.
or.
Again, I'm trying to. I'm trying to confuse you all the time, and I want you to catch those confusions. I'm doing this actually on purpose, or maybe I'm just plain stupid. So you have to, in any case, you have to be awake all the time. So what is the contrary of non-negative?
It's positive and
No. It's the contrary of non-negative is negative.
right? It's negative. Oh, yeah, yes. Yes.
Don't trust
Yes.
this.
Yes. It's
Okay.
just negative. Yeah.
Okay. So we know that the contrary of even is odd. We know that the contrary of non-negative is negative. And we want to turn this, this statement into a negation. How do you do that? You say A.
Yeah, we say A is odd or negative. Yeah.
Say it again, sorry.
A is odd or negative.
It is odd.
A is odd or negative. Yeah.
Yes.
And the or is exclusive or. Yeah.
This one.
Yeah.
And so wouldn't it be A is odd and negative? Oh, sorry about this. Yeah. Wouldn't it be like that?
No, I think no. It's
No.
I think it is need to be a or. Yeah.
Yes. So again, remember that it is important here that or is inclusive and not exclusive. Okay, and in a similar way, negations turn or into and, so that the negation of Tsotsi has black hair or blue eyes is Tsotsi does not have black hair and does not have blue eyes. or if you want, Fuzzy has neither dark hair nor blue eye. So as a small exercise for the next day, because I have to leave now, I want you to give me the negation of x is larger or equals than 1, or x is less than or equal to -1. I want you to find the negation of that. Okay. So, Joao, I think you can stop the recording now, please.